What I have here is a ready-to-ship network deployment. Well, it's not getting shipped too far. Corey's actually going to be installing this. This is one of our clients, our installs, so top to bottom, something we own for one of our managed clients. And this is for one of their locations. And what I have here is a UnIFi 16-port PoE switch, 1, 2, 3, 4, 5 UnIFi AC Pro HDs, and one NetGate firewall to be the head end of this. Now this network's rather simple. It's actually going in an arena, and what I have here is the whole deployment ready to go because we test everything in Office. Test it, set it up, configure it, upgrade it, see if there's any issues, randomly power cycle it. We go through all the steps to make sure there's no problems, and technically it's kind of a burn-in period from when we get it to the install date. We usually just leave it set up and running. That way we know, because generally hardware, and it's not always the case, I know, and there's no exact science to this, but it does seem to fail frequently in its very earliest stages of deployment if you're going to have a problem. Now, knock on wood, with UnIFi, we have had absolutely an excellent track record, and we've never had one of these devices fail out on us, and that's pretty amazing. But you know, that's one of the reasons we like your product so much is because the reliability has been excellent. Some of these have been installed for years, and obviously they're not something you turn off. You leave your Wi-Fi on all the time, and they've been up in ceilings, running in offices that we've been deploying for a long time without any issues. But I still like to test it. I like to test it beforehand, and we have no idea. In one unit didn't adopt the first time we hit adopt. We had to hit the reset button, and it adopted. That was weird. I can't repeat the problem. I don't know what the error was. I don't know if the new guy, because we had him walking him through all this, was at fault at all. But for one reason or another, one didn't adopt after an upgrade, which, like I said, first time that's ever happened, and it was obviously just click the reset, and that's way easier to do before these, which are going to be mounted almost 25 feet up in the air. Before they're deployed, it's always better to have them all up and adopted. I mean, we could do it in post, but probably not the most ideal way to do this. That's because to get to some of these, a man lift has to be rented and then used to put them up. So if you're wondering what the blue stickers are, this is part of the deployment process. So the install and the installer may not be exactly the same person. So our wiring team is going to go out and be doing the install. We don't know exactly where each one of these will go. So instead, we just put numbers on them. 1, 2, 3, 4, and we put it with this blue tape because it's easy to peel the blue tape off. As the installer, which is going to be Corey in this place, as he puts up each one, he'll name the location. He'll be like, Unit 3, and it has a 3 on it, was installed in east hallway, and we have a map of all this, and then he'll put that unit exactly where it is. He'll send us a picture of it for documentation, and in the system, because we're remotely managing this through our cloud key, we'll name it the name of where it was deployed. So that way the setup process, and I was having the new guy do all this, when he runs through, he just has to put some stickers on them as he adopts them. He names them in the system the same as their name right here. So it just becomes a very easy way to deploy them and not have to coordinate the two of them to go, oh no, that one went over here. I meant west side. We wait till the install day to actually name them as we mount them into the hallways and areas that these places are going into. Now I have up here, and I got it turned around so you can see the network cables, but this is the NetGate SG3100. And I'm showing you how it's plugged in. Now at present, this client probably won't be doing redundancy in terms of internet connection. It's a maybe. They talked about it. They're deciding if they need it or not, because this is a sports venue kind of stadium area. That's also why there's not a bigger switch. That's also why we use high density Wi-Fis, because a lot of this is dedicated towards their guest network. They only need a few things in the office, and the NetGate SG3100 is capable of failover with 2 internet connections, and certainly capable of gigabit routing, despite what people keep telling me it's not. I tested it, I have it deployed, it works perfectly fine. So we're just using the WAN port. The Opt1 is the optional port that can be used for different things. We're going to be using it maybe for redundancy, but for now the client's only getting one internet provider, so this is going to be perfectly fine because, like I said, a lot of this is dedicated to a guest network. Then we have one cable, and that's why I wanted to show you just one cable going out of the LAN side with VLANs on it. So you don't necessarily on the SG3100 now need to do anything. These have 4 ports on here that act as a standard switch ports. So this is technically like one logical port here, then the WAN's a logical port, and then the Opt1's a logical port. That way I can use each of these and program them, but then I just set the VLAN to come out here, and then it goes right into the UnIFi. We're going to get into the software setup here in just a second. From there, one is the main LAN, which is for the office people and administration, which there's only a handful of. There's going to be, I think they said 7 people in the building that need computer access, so pretty minimal there. Then the other side is the VLAN is for the guest. That is the larger side of the network. And of course, with the guest network, there's a couple rules that we'll talk about. We have AP isolation because we don't want the guests to be able to see each other. So we have that deployed in here. We're not worried about a guest portal. They do want a password on there. And what they do with their guest access is they have a password up on the wall. And I know someone's gonna say it's not the most secure. Yeah, it's not really supposed to be. It's a guest network, and that's kind of the idea. So each guest is isolated, but occasionally they change the password to be something promotional. So that's something to consider. They didn't want to go with the captive portal. They said that they don't want to make it a challenge. Just give a password, and all the guests that are fans of ours can just come in there. That's what they plan now, but we can always change it. As I know, it's captive portal is both supported in UnIFi, or we can even put a captive portal into the NetGate device, and you can set all that up too. It's in the works and consideration. These are sometimes things that get changed in post from the client. This is what they told us now, but the venue doesn't open for a little while, so we're getting on the ground floor and putting all this physical layer stuff in, and maybe later it'll change it, and that's the beauty of the way this stuff works. It's just a few commands to send it back out and modify these to do it however they want to change it. But it's a pretty simple setup, and this is a very common setup. And now I'm going to jump now over to the network side of this and log into the NetGate, log into the UnIFi, and actually show you the settings that we put in there and kind of walk you through the why of how we set this up in this pretty simple network. Okay, so we'll start at the pfSense and talk about the network settings. I know because this is in our internal networks. For those of you wondering, this is not a public IP address, of course. 192.168.3.220. Like I said, it's plugged into like our general network that we have here at the office. Here is the LAN that is going into that. It says 2500 base key exfil duplex. This is the 4 ports that you have right here for the LAN. So LAN 1, LAN 2, LAN 3. This is the logical network for it. These are the different physical ports that are on there. So when we look at the LAN, we have it set to 192.168.10.1. And whenever you're setting up any type of business network, just don't make it 1.1 or 0.1 or 10.1.1, because the 10 series, pretty much 10.1.1, if you put it in that, it may work, but it's also the default for Comcast. If you use 192.168.11, that's the default for, well, a lot of consumer routers, and 192.168.01 is a default for a lot I've seen of the D-Link routers. I know there's probably a few others that use this. And the problem you run into is if you have to do a VPN later and you end up with another network, you want to start out with the business network being something a little bit different, because a lot of the home users connecting when you set up the VPN, or if you're an existing network that was kind of amateur set up, you frequently see 1.1. Well, then you have to decide about how you want the routing to do when you ever want to VPN these networks together. That may never happen at this client, but it's still kind of a practice I follow to set this up. Now, /24. Like I said, maybe 10 devices at most. Probably, I think there's 7 people in the office. There are not going to be a ton of users or devices on the business network. There's just not a lot of staff there. It's pretty basic and straightforward. So I don't really have to worry about allocation on there when I set up the DHCP server. Now, we're going to go over here to assignments, and we're going to take a look at the VLAN. And we built this VLAN 20. And we descriptively called it guest network, VLAN tag of 20, interface assignments. It's called guest network, VLAN 20 on LAN. So MVNETA1 is that LAN port. This is VLAN 20. So all of that is being trunked right through. So all the VLAN data goes through to the UnIFi because it's sharing just that one cable you've seen at the beginning. So then we look over here and we go to the guest network interface as we named it, and we see that this is a 172.16.0.1, and we did a /22. And the reason we did a /22, and I'll go over here to the DHCP server. /22 will give us the range of 172.16.01 through 172.16.3.1.254. The reason you want a fairly large range is because there's a bunch of random people, and the majority of these are going to be phones that are connecting to this. So not a ton of bandwidth, but a lot of devices on there. So once again, we're going to cover in a second how we do the AP isolation, but you want to have a wide range of people. Now this is also going to drive over why I'm using these, the high density UnIFi APC HDs, because they support up to 500 clients on one. And because of the way this is laid out, first people may be in the arena area because it's a sporting arena. Then they may move over to a large bar area where one of these will be. So we have a high density of people kind of clustered together. So there may be a lot of them per device. Now, one of the things that people ask about capacity planning is, one, make sure you always go a little bigger if you can. And in this case, these are very reasonably priced and have the support for 500 client connections on there. They're very fast. We found them we deployed these a few times. I found them very reliable, especially with these high density groups of people on there, and still able to maintain a good system. But when you kind of ask the question of capacity, you also can do things like find out what the fire marshal said is allowed in the building. Oh, there's only a maximum capacity of 1,100 people in the building. Well, I know, and you just can't push in the range of one of these 1,100 people in that dense of an area. So we know each area is capacity listed by the fire marshal. So we know there'll at least be that many people, or maximum that many people in there. So you can kind of plan accordingly. So we know that we'll never oversaturate these, but we know potentially spread out through the building, because there's more than one arena area and a very large like bar area. There's going to be a high density of users. So that's where we chose these, because it's able to really have no problems with Wi-Fi and interference. But whenever you're setting up, and just a general rule for subnetting is never put more than 1,000 devices per subnet, because it can get noisy and a lot of traffic on there. So if you are getting bigger, that would go beyond the scale of what I'm deploying right here. But for what we're doing on this here, it's not likely that every one of these, all 5 of them, will get 500 users, but it's that density of users moving around is why we chose these units. We probably still could have got away with smaller ones, but honestly, for the price difference and everything, we went ahead and went with these HDs because they're very reasonably priced. They're not substantially more. MSRP of $349. You can frequently find these for, I think we paid under $300 for them when we got them on sale. So, or if you buy them in bulk, you buy 5 at a time or 4 at a time in a bulk pack, you get them cheaper as well. So that's the ones we went with here, these UAP HDs. So now I'm going to go back over to the settings, and we just use pretty much the whole network. So we started at 172.16.0.10, 172.16.3.250. So there's quite a few IP addresses that can be assigned there for different devices that jump on and off the network. Now, in the way it works here in pfSense, we have the LAN network and then the guest network are separate. I like to put, when I'm doing a separate like guest network, any completely different range. That's why I chose the 172 range. It just makes it really easy if you're ever doing any troubleshooting. You know, if it begins with 172, it belongs to the guest network. There's no hard, fast rule about this. This is kind of a convenience thing for when I've set up a lot of networks. I know right away if I see some problem or I'm just generally looking through logs, 172 is stuff coming from the guests, 192 is coming from the office. And if I ever had to build out another separate network for the office, let's say for like a credit card network or a point of sale system network, we could build a like LAN 2, another office network, and still keep it in the 192 range and just not use the .10, use something else, create another VLAN, and the same thing. It keeps kind of a consolidated way that I view things. And I wanted to make sure I mention that on the guest network, we do allow access, and we have this, which means they can't access the LAN net. So here's your guest network versus LAN, and we want to give them internet access, but not access to local networks. Now, normally I would have done this in an alias, and you alias in all the different LAN networks, but there's only one, so we simply, and I'll edit the rule real quick here and show you, we allow the source to be any. Invert match means LAN network. They cannot get to the LAN network. Now, this is also further protected by the routing within the UnIFi devices, which also, when we apply guest network policies, stop them from seeing both each other and other local devices through exclusions set in the guest policies. Now that's pretty much it for the firewall setup. Not a lot to it. It's pretty, like I said, straightforward. There's not a lot on here. I will probably load PF Blocker on here. That's about all they really need to make this system work. And like I said, potentially fail over if they add it later. Now let's jump into the UnIFi side of the configuration. So in the 16-port PoE, we have the one uplink port, which is this one here. So this is actually where I plugged it in for the uplink. And this is where all the data is coming in from the pfSense box. So just to follow me on the VLAN setup here, we have the 4 ports, the switch ports on the pfSense. We have one cable coming out of that and going into this port, which becomes the uplink port. There is no special settings on this. Switch profile all. So we do see the LAN and guest, but you actually want the full all profile, because we're not at this time splitting out any of the PoE ports or ports in general on the 16-port PoE switch to be their own VLAN. Because if you wanted to, you could plug in the Wi-Fi and use the example of like this port here. Let me close that. And we could look at this port and we could edit this port and we could say, hey, port 3 has one of the Wi-Fi devices plugged in. We could say, hey, make that only the guest network. But ideally, the reason we don't do that is because you want them to be able to get all the profiles, because you want to do the actual VLAN setup inside of the devices themselves. So let's show you how we do that. So first we're going to go here to settings. We're going to go here to networks. So here in networks, we have our guest network VLAN only, and we have our LAN. And how do we create this? Well, it's pretty easy. You can literally hit create network and hit VLAN only and put the VLAN ID in there. Pretty straightforward. So we'll actually edit this one real quick to show you. We named it guest network because that's what it is. This is just our own naming convention. VLAN 20, which matches VLAN 20 right here. So, you know, we have to keep all that matching. So guest network, VLAN only, VLAN 20. Pretty straightforward. Here's the corporate network LAN, and we just left this at 192.168.10.1/24, so it knows what the network settings are. So we have the LAN corporate here, so that's set and configured, and that's going to get everything. Now here's where we build the wireless networks. I have one called guest network, one called office network. This is not the names they'll get in actual deployment, but for the nature of this video, and feel like putting the company name in there. So guest network, WP personal, and we do have a password on it. The other thing we checked here is apply guest policies, captive portal guest authentication. You set the guest control policies. We have it set just for really the isolation, and that's an important piece. So that's in the guest settings. I'll get to that in 1 second. This is the part that is important. Use VLAN and then what the VLAN number is. So we use VLAN 20. That slices off all the data coming to there. So all the data goes from the pfSense out of the port into the 16-port PoE with all the VLAN data. The whole is referred to as a trunk data. So everything comes through. Then it goes through all the way to the Wi-Fi devices. So the access points get all the data. And then they can slice out the VLAN, which is VLAN 20, and they slice it out and put it on its own SSID. So when we create this guest network SSID, VLAN 20 is sliced out of there, and that becomes that 172 network. I'm going to go back over here to wireless networks. And with the office network, what we're doing here is not using a VLAN because we do the office. Now, if we were to set up another office network, or you wanted to create further isolation, but the office network is the trusted network per se, you could create a separate VLAN just for the office network. That way you have a management network, an office network, if you really wanted to break things down really tight like that, but it doesn't really need to be in this use case. There's a few computers on there for updating scores and things like that that the office people will be using. But all that data is coming through that wireless network, and so we don't need to break this one out. It's going to pull the 192 network. And so back to a little bit how VLANs work. All the data comes down the pipe, and we're using the access point to slice out that VLAN and remove that tag data. So it is carrying over one single cable. And if we ever needed to have more bandwidth, these do have the dual cable support, so you can bond them together if there was a speed issue. But you got to remember that too, is that on the physical side of it, one cable is carrying both networks. It's just segmented out inside the VLAN. Now, the last little thing I want to cover here is the user group is guest network, not default. Now, this is because we're using the access points themselves as a layer of protection for not giving them full bandwidth. And they generally don't. You got a bunch of people there because this is going to be a lot of kids playing sports, and it's a lot of parents who are going to be taking pictures and sending them and uploading them. That's why they need the guest network on there. And that's what this user group is for. But we have a user group called guest network. So default is unlimited bandwidth. Limit bandwidth to 2 megs, limit upload bandwidth to 2 megs. And what this is doing is slowing down their network. So the service they're getting is a 500 meg circuit going in here, and you don't necessarily want all the users to have full all the time. Now, they don't all the time. Phones are somewhat efficient unless they're watching YouTube or Netflix. They're somewhat efficient about their data usage because, they kind of expect it over 3G, but you don't want to give them just a full pipe on there. So each one of these limit download bandwidth to 2, limit download bandwidth to 2, and away we go, and we're good. Later, we may do, if needed, and this is actually the second deployment. This is another location for this particular client. If needed, we can also have pfSense do some traffic shaping. But at the other location, we haven't had an issue, and they have quite a few guests on the network, and it hasn't really caused any problems. But an option we can do is traffic shaping, where we prioritize one network over another, and that's reasonably easy to do inside of pfSense. You can also just put restrictions on that network, like hard limits, and say this network can never exceed this much bandwidth, and then everyone the phones can all fight it out for the available bandwidth on there. But so you have to do, though, because we're going to start at the UnIFi, at least limiting so no one phone can have more bandwidth. And 2 megs is not super fast, but it's fast enough for them to, update Facebook and tweet out pictures and Instagram things. So it's good enough for that. It'll get the job done. And that's one of the nice things about things like Instagram. It does cut the resolution down, making that a little bit more, less of a challenge getting the data out. So that's pretty much it for the setup here. It's pretty straightforward. And like I said, you can see how we did the naming scheme, naming them, putting the blue stickers on them. So now once they get installed, we just go through each one and are going to rename them as they get installed. But pretty easy to do. This will be called, hallway or wherever it goes in each location. Then we overlay the map on there, and then the system's deployed and we manage it. It's pretty straightforward setup. But that's it for the video. Hopefully this was enlightening. This is literally a job that's going to be installed. I believe the job is scheduled for Thursday right now. If I have a chance, I'll film some on-site there getting this built out, which would be pretty cool. But I don't always have time to do that, so I at least wanted to show you the prep work that goes into a deployment like this prior to the deployment. So these are all the things we have to get ready in the office for this. And we do this sometimes for other technicians. So in this case, this is a job from top to bottom that's ours, and it's another location for an existing client doing the same thing, having a stadium venue where they do sports training. And, a lot of parents there bringing their kids to the sporting event. This is, like I said, a repeat of something we've already done before, so we know this whole setup works perfectly fine. But we do this as well for other technicians that just want to do the physical layer and have us help with the setup work. Because managing this is not too hard to do. A lot of it does come down to getting it set up is the important part, and kind of thinking through, all right, this is how I want to do it. This is the layout I want to do. So hopefully this was enlightening, or maybe you have comments, concerns, or things you think I could be doing better. I'm always, listening to feedback, because how we do things is always shaping and changing over time, and we're always trying to improve processes and become more efficient when we do this. But this is going to sit on a desk running for, like I said, a couple days until it gets to the deployment time, and from there it gets sent out and works. So that's it. Thanks for watching. If you like this video, go ahead and click the thumbs up. Leave us some feedback below to let us know any details, what you like and didn't like as well, because we love hearing the feedback. Or if you just want to say thanks, leave a comment. If you want to be notified of new videos as they come out, go ahead and hit the subscribe and the bell icon. That lets YouTube know that you're interested in notifications. Hopefully they send them, as we've learned with YouTube. Anyways, if you want to contract us for consulting services, you go ahead and hit lawrencesystems.com, and you can reach out to us for all the projects that we can do and help you. We work with a lot of small businesses, IT companies, even some large companies, and you can farm different work out to us or just hire us as a consultant to help design your network. Also, if you want to help the channel in other ways, we have a Patreon. We have affiliate links. You'll find them in the description. You'll also find recommendations to other affiliate links and things you can sign up for on lawrencesystems.com. Once again, thanks for watching, and I'll see you in the next video.